Shall we start? Yeah. Okay, cool. I guess, first of all, good morning, everyone. Thank you guys for being here and to listen to me talk about debunking serverless myths. I've got my water perfectly positioned so that I don't destroy another laptop. Funny story, I'll tell you another day. So my name is Yan Cui. I'm a destroyer of MacBooks apparently, but also I've been a long time user of AWS as well. I've been running workloads in production on AWS for almost 10 years now, including one of my previous startups where I moved the social network to run pretty much entirely on serverless. As you can see, Lambda being a sort of very important piece or the puzzle that connects everything together. So nowadays, I spend half my time working with Lumigo as a developer advocate, trying to teach more people about serverless, how to do it well. Lumigo is a troubleshooting platform for service applications. There's some more space over here if you guys want to come over this side.
Sorry.
That's okay. It's okay. So that time I was telling you about when I destroyed my laptop.
Sorry.
Yeah, I was in the bath and I started watching TV on the laptop and then I slipped and boom, and then the water went over the laptop everywhere. So, all right, people are still coming in? That's okay, that's okay.
Well, you are popular.
I'm really humbled. Okay, let's see. So as I was saying, I'm just talking about myself, so it's not interesting, just keep coming in. So nowadays, I also spend a lot of my time working with other companies around the world, try to help them follow best practices when they want to adapt serverless, for example. But maybe I should start with what do I mean when I say serverless, because you probably hear this word a lot, and I know for a fact that every time I say it, someone would raise their hand and say, but there's still a server somewhere, which is, of course, missing the point completely. And I think Goiko says it best when he says that serverless is serverless in the same way that Wi-Fi is wireless, because even with Wi-Fi, there's still cables running around, right? You just that when you connect to a Wi-Fi connection, you don't think about those cables that's connecting the router to everything else. So serverless is the same thing, that even though there's still servers running your code, but you don't have to think about those servers by and large. So when I think serverless, I think any technology where I don't pay for it when I don't do anything with them, so that when there's no code running, I don't pay for that server. And that I don't have to think about, as a developer and engineer, to think about scaling, to have to think about how to patch the server for the latest security updates, auto scaling, and all that stuff. And you may also hear this phrase, functions as service, and this is where you will find services like AWS Lambda, Google Cloud Functions, Azure Functions, and so on, where it's actually a very accurate description for what we actually do in terms of writing a very small piece of function. We upload to the cloud and tell the cloud how and when to call our function. It could be when someone calls an HTTP endpoint, or publish a message from an IoT device, or publish a message or something happening in our AWS cloud and trigger some event happening in the CloudWatch event. So when you compare function as service with other as a service things such as infrastructure, container, or platform as a service, as you can see from this diagram, is very close to platform as a service. The main difference being the unit of deployment and scaling is now the individual functions that makes up your entire application, not the application on its own, in its entirety. So by my definition, you will find there are other services that should also be considered serverless as well. Services such as S3, for example, where you can get infinite storage without having to think about how the server is managed, updated, and then scaled. At the same time, you can also find some of the functions of service things out there that may not be considered serverless. For example, you have options to run, say, functions of service on top of your own Kubernetes cluster, but if you're still running and managing the cluster and then the Kubernetes setup on top of that, then really you're still paying for servers when nothing's running, and you're still responsible for setting up scaling for this underlying infrastructure and servers. If you ask people like Simon Wadley, who is a widely respected figure in the sort of DevOps space and IT in general, many of us are really confident that in the future, serverless will be the primary way that we use to build businesses around technology, not building technologies. That's an important difference. Why is that? I think for starters, you find that your application running on serverless technologies can be very scalable, probably scaling a lot faster than compared to your counterpart running on EC2 and containers, and that when you don't run the workload, say 100% of the time, you can also find the application may be a lot cheaper when you move them to serverless. I can speak to that from my personal experience as well, where when I moved everything for that social network to serverless, we cut our costs down by about 95% compared to what we were paying on EC2, because we were paying for a lot of CPU cycles that just weren't being used. With Lambda, you get multi-Z out of the box, so you get a very good baseline redundancy without having to do a lot of work yourself, and also you don't pay for those extra redundancy, again, when your code is not running. And since AWS is now taking care of the security of your operating system, as well as network configurations around the servers that runs your code, you also find them to be more secure as well. You don't, for example, when the Spectre meltdown happened, AWS patched all the servers that's running Lambda without me even having to think about them. Whereas at the time I was busy patching, I think, 50 different AMIs for the different clusters of EC2 instances I was running. But the big thing for me, still, with serverless is that from having an idea to having something actually running in production, so I can test the idea against the market to find out, is this even a good idea that's worth investing into more effort into perfecting. There are just so many things I've got to think about, from configuring AMIs, auto scaling, capacity planning meetings, and all of that, that when it comes to serverless, by and large, they become either irrelevant or have largely been simplified so much that it can be automated with simple tool. So in return, I've got this super highway. Don't worry, the slides are available afterwards. I've put it on Twitter. In return, I get this super highway from having an idea to having something actually running in the market so that I can test the idea by minimizing the amount of undifferentiated heavy lifting that I and my team have to do ourselves, and therefore means there's less things for us to manage going forward, so that we have less operational responsibility on a day-to-day basis as well. And that translates to having more of our time and energy spent on things that will actually make a difference to our customers. So that sounds great, right? Everybody, of course, wants this, spend more time doing business value than everything else. But you may ask, what about containers? Are we just going to ignore the elephant in the room? I think containers going forward will still be a very important part of the ecosystem, probably more so than even it is now, but it should ultimately be invisible part of the system. In the same way that today, if you run anything on a cloud, chances are you're running on a hypervisor. But nobody in this room is right now thinking about, I wonder what can I do with the hypervisor, right? It's the invisible power system, a very critical part, but ultimately not something that we should be thinking about as application developers. You don't have to spend much time on the social media to find that there's massive chasing between people in the containers camp versus people in the serverless camp. Of course, I'm biased, I'm very much in the serverless camp, but that said, as an engineer, serverless is still just a tool. I don't really care about a tool per se. Having serverless is not the goal. The goal should be and always is to build products that your customers would love to use. And a lot of time, especially for new products, that comes down to how quickly can you test ideas against the market and iterate on those ideas so that you can first find the good ideas from hundreds of bad ideas you have. Let's be honest, everybody has more ideas than they can do with them, and only a few of those ideas are actually good ideas that people actually want. And once you identify those good ideas, you want to be able to really quickly iterate on that and then make them better and deliver things that your customers actually want. And to do that, you want to spend less time owning technology, but spend more time focusing on how can you create business value for your customers and for your business, for your organization. And I think serverless just happened to be a very good fit for this general mentality, this mantra of how we should be doing things. That's not to hide the fact that a lot of technologies that we're talking about today, in terms of Lambda, Azure Functions, and others, they're still very much maturing. There's a new paradigm. There's a lot of, the changes people have to go through in terms of how they build systems. And which is why you find a lot of different myths or misconceptions about how things actually work, which is why I'm here today to tell you a lot about things like how costar works, the serverless costs, the need for control, and the big one that everyone always asks me, which is about vendor lock-in. I get this question asked every single time I speak at public, so I might as well just throw it in there before you ask. So, starting with costars. Now, ultimately, Lambda still runs on some machines. So imagine there's no request comes in. Lambda says, okay, I don't have anything running for your function right now. So what I've got to do is, in this case, I've got to create a container. Well, find a space to allocate a container first. initialize it. And then if you're talking about JVM and other language that's got like a runtime, then you have to initialize the runtime, and then you have to initialize your module for your function before you can actually go ahead and invoke your function inside that module. And one of the things I've heard quite a few times is this misconception that, well, costars only happens once, right, on that first request. I see someone shaking their head because you know, but for those of you who don't know, really is the first request to a new container that's been created. And I think the problem we have in this case, why we have this misconception, is that there's we don't have a language to differentiate between a function, a concurrent execution, or a container, and an invocation. And I think that's actually a good mapping to what we know from, say, OO, whereby we have a class, a blueprint for what what a function should do. We have the instance of that class being a container, and then an invocation is a method call on a particular instance of your function. Now, Lambda will also scale the number of instances that it needs to run to meet the traffic to your function, which is great. But what it also does is that making sure when the request comes in, if there's a container that's free and sitting there not doing anything, then you reuse these containers as much as possible for performance so that you don't see costars on every single request. So let's walk through an example. A request comes in, no container, so we create a new one, therefore we have a cold start. And then another request comes in around the same time. Again, that one is really busy, so we have to create a new container and therefore another cold start. But then nothing's happened for a while before another request comes in, 2 at a time actually. In this case, we have 2 containers. Perfect. We keep them both busy. Unfortunately, another 2 comes in, so again, 2 more containers, 2 more costars, and so on. Nothing happens for a while, and then we get another one, so we run the invocation on one of the available containers. But the others haven't been used for a while, so after a short period, they are garbage collected by the system. And then eventually, even this one that's been used for a while, now has been idle for some time, and will be scaled to 0. So that you don't pay for anything when the system is just idle and not doing anything. What this means is that if I've got, say, 100 requests at a concurrency of 1, only that first request will be slow, because you have to pay for the cold start. But after that, all the requests are fast. But if I'm doing 100 requests, but this time in 10 at a time, that means all 10 of those batch of first 10 requests are all going to be slow, because they're all going to involve creating a new container to handle the requests. Now, this is important because when you think about costars, you need to think about in terms of frequency, how often do you see that, but also how long is a cold start. For frequency, is something that you can't control. You can't tell your customers, okay, you come in at 5 o'clock and at 5:01, just so that you can space them out nicely. So there's nothing you can do to control the traffic for anything that's user-facing. For your own system backend things, of course, you can just decide when to run them. So instead, you want to focus your efforts on optimizing the duration, how long the costars run for, so that even when they happen, they're not that bad. Before you decide that, okay, that's costar, so Lambda is off the table, it's not good enough for my use case, it's important for you to first decide what is your latency requirement. Especially if, for example, you're building something like web application. By and large, most people will accept, say, 1 second or even 3 seconds as a 99th percentile, and that's good enough for most. And if you're doing something that's in the sort of background processing, then occasionally seeing a 3-second on the background processor, it doesn't matter because the user is not seeing that latency. And you've got Node.js functions or Python functions or Golang functions running with, say, 1 or more gig of memory, no VPC, then you can actually expect costar to be up to be as low as about 500 milliseconds with a very minimal amount of optimization. And that's good, again, good enough for most web traffic that I have come across. And also, don't pretend that this sporadic spike in latency is a brand new thing that is introduced by Lambda. I've had this for so many years before, that you have GC pauses, if you're working with JVM or .NET, you have occasionally just stop the word garbage collection happening, so you see 1 second code, you have 1 second response time for all of your requests for that period of time. And when server gets overloaded because they're handling more and more requests, then you start even seeing performance worsen even more. If you remember running stuff of EC2 and containers, as the traffic goes through your saturation point, latency is just going to spike through the roof. Now that Lambda is handling 1 request at a time, by and large, you don't see those drastic increases after your server gets saturated. And also, we have to deal with a slow response time from third-party systems we depend on, or databases and so on. And then there's also network issues which still can happen for Lambda. And also, if your traffic is just steady, just constant 50 requests per second, then by and large, you're not going to see that many cold starts anyway, because once the containers are created, the traffic will just keep it warm. For example, IRobot, as they increase more and more robots, their total traffic requests per second will increase, but it's still by and large steady. So when I speak to Ben Cahill from IRobot, his response to what about costars is meh. It's all robots, so no one sees it, and also the traffic is so stable that they don't really see that many of them anyway. On the other hand, if you work for, say, a live sports streaming platform where everybody logs in like 5 seconds before the match starts, then you're going to see crazy spikes in traffic. So you're going to see a lot of cold starts when that happen. Or if you're working for, say, a food delivery service whereby everybody logs in between lunch and dinner, but then nothing in between and afterwards, then again, you're going to see a very spiky traffic. In which case, since you can't control how often you see cold starts, you want to make sure that you optimize the cold start duration so that even when they do happen, the cold start, the latency still falls within what is acceptable for your application. There's quite a few things you can do. You can use a high memory setting, which gives your function more CPU and also more network bandwidth as well if you're doing anything that's remotely CPU intensive. And if you use functions in Node.js, Python, or Golang, all of those have very low or minimum overhead for for starting up the VM and so on. So if you're using Java and .NET, then you have to bootstrap. CoStar involves booting up the runtime, which means you're going to look at maybe a second or more. And you can also trim your dependencies, and for Node.js functions, if you use a bundler like Webpack, they can also help you a lot in terms of reducing your cold starts. And it will also help in terms of trimming your dependencies if you keep your functions single purpose. So if you have one big function that handles all of the API traffic, different routes and different endpoints, then that means that single function has to have the dependencies to serve all the different requests, which means that you're going to see a worse cold start as a result. And for now, until the VPC enhancement has been rolled out from AWS, has been rolled out to all different regions, you should also avoid using VPCs, because VPCs requires ENIs, and when you have invocations that requires a new ENI, then you're looking at 10 seconds being added to your cold start time. And this has been fixed as we speak. It's been rolled out to, I think, 4 different regions, including Ireland and Frankfurt, but the US region hasn't been updated yet. And that brings us to cost. A common argument I hear a lot against using Lambda is that, well, good luck when AWS decides to play yo-yo with your pricing for Lambda. That's fair concern, but that's completely being ignorant of the fact that market force just means that they will never do that. If you do that even once, your customer is just going to go flood to Azure, and you're just going to not have any customer doing that working with you. And also, historically, the data is just not there to support that this is a thing. That AWS has got this history of raising prices on a whim, which just doesn't happen. And yet, I still see a lot of blog posts that talk about how, okay, when you're using Lambda for some things, it's just super slow and super expensive. This one came out, I think, late last year, where some researchers used Lambda to do machine learning and also model training and the low latency prediction serving, and they found that the Lambda was more expensive and also slower as well, because it's just not a good fit for the workload they were trying to do. And then this one came out recently. It was on the Hacker News, on I think top of Hacker News for about 3 days, where it talks about how he moved his application to Lambda and became a lot more expensive and whatnot. But when you read through the post, he's actually making a mistake in that he's using API Gateway instead of ALB, which is more expensive when you have a lot of traffic going through that. And after lots of feedback, he did update his post and acknowledged that he could have, one of the mistakes he made was using API Gateway in this case when he's got a high traffic system. The problem here is that from the outside, Lambda looks so simple, so you see a lot of people just jumping in without doing the research. And my friend Joe afterwards tweeted about how a lot of people, if you spend 2 weeks researching instead of going straight in, you save yourself a lot of time in the long run, because you find out all the different edge cases and constraints that you find out later if you just didn't do that research earlier. That said, there's a very famous Chinese proverb that says there's no such a thing as a bad student, only a bad teacher. And for that, I put the blame on the AWS and other platforms for not doing enough to educate many of these customers. I got so many people asking me, okay, I can do all these things with Lambda, but when do I use API Gateway versus ALB? There's just no documentation or any guides on how to tell you to choose them. And when it comes to queuing, it gets even worse. You've got SNS, SQS, Kinesis, starting with DBString, KMS, just to name 5 that I can count on the top of my head. How do you choose between them? There's nothing from AWS that tells you, in this case, you should use SNS, and in this other case, use Kinesis. But if you do use Lambda in the right places, a lot of companies find that they can save a lot of cost. Financial Engine in the US found that they save the cost by about 90%. There's a new study from CloudWoo. I think they only spend something like $10,000 a month to serve a couple million monthly active users. And there's also another independent paper by the guys from Imperial College that found that people finding a lot of saving by moving their workload to serverless as well. But all of this is still just looking at a very small piece of your total cost or ownership, whereby we're just looking at what's on our AWS bill. Because that's a number that we can easily measure and look at, and it's a well-observed phenomenon that what gets measured gets optimized. So we find people spending a lot of time just optimizing what the number they can see, ignoring the fact that there's so many other things that counts towards the total cost of ownership, and that for most companies, the biggest thing that they spend on is the people, the engineers, the brain power they have in the company. They have to spend so much money recruiting them, keeping them happy, buy buildings to let them work. And then most of the time, most companies only care about the biggest cost they care about is time to market, because the cloud is an enabler that allows pretty much anybody to disrupt the market. Even small companies nowadays can do things they just couldn't get into the door 10 years ago, which means that all of us are working in increasingly competitive spaces, and the time to market, the first mover advantage, is very important. Most companies I speak to cares an awful lot about time to market, and yet they spend more time and energy on this. And when most of your budget is spending on people and brain power, does it not make sense for you to do whatever you can to give them, to make more use of that brain power that you're spending money on, to let your engineers, to give them better leverage to be able to do more with less, by taking away the things that they have to do constantly and getting in the way of them trying to actually deliver something. The amount of times in my career where I've spent 10 days doing all of this just so that I can spend an hour doing the actual feature at a new endpoint is crazy. And nowadays, it's completely reversed. I don't have to worry about any of this anymore. I spend that 1 hour writing my business feature, ship, done. Because Lambda gives me so much out of the box. I've got blue-green deployment out of the box. I've got auto-scaling, multi-AZ, all the things that I used to have to build myself. Sure, depending on your traffic and your workload, you may find that Lambda doesn't save you any money on AWS, but in return, it may sometimes even cost you even more, but in return, you can get so much more done. And I can attest to that based on my personal experience, having gone through the transformation of running things on EC2 and moving them to run on serverless. In the process, with a very small team, by the way, very quickly, and we also added a lot of new features, which was a driver for this change, this migration, this move, so that we can deliver features faster. We also made massive savings against running the same workload on EC2, but also increase our feature delivery. We went from taking months to deliver a new feature to sometimes discuss, implement, test, ship, and put something into production all in the same day. And when things start moving faster, generally speaking, everybody in the company was happier. Except for those of you who still want to have control. And the funny thing is, when you say control, everyone wants to control. It makes them feel good, makes them feel safe. But you're ignoring the fact that on the other side of control is a lot of responsibilities. And this quest for control has happened always, has always been there, that everybody wants control. But no one is thinking about the price tag on that, having that control. Because controlling infrastructure means you're taking on a lot of responsibilities that requires additional skill sets in the company to be able to take on those responsibilities. And that means having engineers, which are not getting cheaper, by the way. Good news if you're an engineer in the room. Bad news if you're the guy that's paying for them. And then you also have to have a lot of admin costs in terms of building support structure, having managers, office admins. You have paying for the office space to have people to let the engineers do their best work. And also you have to spend a lot of time doing recruitment, time that you could have otherwise spent on just building the things that you need to do. And also, as you remember, time to market as well is a massive cost for a lot of companies, especially again, you're being disrupted by faster moving competitors who can outmaneuver and out-innovate you. So when you think about any decisions, think about the total cost of ownership of what you're doing. It's absolutely fine to pay for that control if you say you have some business critical workload that you really need high performance, high predictable performance, say sub 10 milliseconds. Okay, Lambda has no way of providing that right now, so absolutely don't use Lambda for that. Or maybe you have a regulatory requirement that says you have to be able to move from AWS within 30 days. Then again, you can't rely on Lambda for those. Absolutely fine to pay for those requirements, but guard against the temptation to look for control for the sake of having it because it makes you feel good. I see so many people try to build a custom containerized, container-based, general purpose platform that is just a poor imitation of what you can get out of the box with big providers like AWS and Google and so on. So it's all well and good making decision to not use Lambda, but always start with why are you doing this? What is the biggest problem that's facing your organization, and what's the most efficient way you can solve those problems? Be it containers or serverless, doesn't matter, but understand why you're doing things first. Which brings me to the most frustrating question I get all the time, which is, what about vendor lock-in? Which again is just looking at one side of the coin of a risk of being locked in by AWS or whoever, but not looking at the other side of that coin, which is the reward. And also the most frustrating thing about all this is that it's not even a lock-in. I mean, sure, you're making a decision to use a particular platform that's going to have a switching cost if you change your mind later, but you can still do it. It just takes more effort. And a lot of time, the same happens, actually no, all the time, this same happens whenever you make any technology decision to say use Node.js or to use Express or to use some other framework. I've seen so many companies struggle to even get out of a web framework that they chose to use 3 years ago, let alone a compute platform. But the same problem exists, and all those decisions have got switching cost. So you either pay for that switching cost when you decide to make a change your mind to make a change, or I see a lot of this frustratingly often is people end up spending a lot of time upfront, potentially paying even more of the switching costs upfront in order to build up all the abstraction layers so they can then later on make it easier for them to switch over to different to change their mind. And in between, a lot of complexities that created up front is just going to still slowing you down. You're still paying for the complexity all the way through your development cycle until eventually you do want to change. There's still some work that have to be done anyway. In fact, doesn't matter what you do with compute has always been easy to move around. What is hard is data, because data is probably a much bigger form of lock-in, because data has got gravity, is economically incentivized to stay exactly where it is, accumulate, get as big as you want, and then become really hard for you to move it anywhere else. In fact, that is known as the Newton's 41st law, that data has gravity, swiftly followed by his most important law, 42nd law, that data migration is going to suck for everybody. So I saw this poster show up on the Martin Fowler's blog recently. I think it's great. It talks about the cost of avoiding vendor lock-in in terms of oftentimes you just end up exchanging one lock-in for another form of lock-in, and also talks about how lock-in is not just in terms of how much engineering work you're going to do to make a change later on, but also comes in the form of legal contracts. If you sign up with a private cloud provider, it comes with cost, it comes to lock-in with the expertise that other people provide you with. It's all well and good having Docker images that you can move to somewhere else, but if you don't have the expertise to run that infrastructure yourself, guess what? You're still locked into someone else providing the skills that you need. And complexity is by far the biggest cost you're going to pay, because it's not just upfront, you're going to pay it all the time. Still, I hear a lot of shouts about vendor lock-in is the root of all evil, and completely ignoring the fact that there's so much cost involved with trying to avoid that lock-in. And you may say, that's okay for us. We have a whole team of people that knows this stuff. But even if you have got expertise, can you maybe think of something else for them to do that can create more value for the business instead of just looking after infrastructure? In fact, the creative Envoy, who many people actually use to run their containerized workloads on Kubernetes, said recently in a podcast that unless you are an infrastructure company, infrastructure is basically overhead. Now, let that sink in. This is a guy that created one of the most important tools in the whole Kubernetes ecosystem. And he doesn't even think infrastructure should be what you should be focusing on. And again, risk is just one side of the coin, and the other side of the coin is reward. And if you have invested into anything ever, you know that if you don't take on any risk, you can't expect to have any reward at the end. And in this case, the reward for embracing a cloud platform and use it the most you can is being to extract the most value from the cloud partner, and also minimize the amount of work that you have to do yourself and increase your time to market. And whilst a lot of people are concerned about Amazon locking them out of their kingdom, I'm more concerned about my competitor locking me out of the entire sector because they can outmaneuver and out-innovate me. And the way my best defense for that, against that, is again focusing what energy and time I do have on creating more business value instead of trying to own more and more technology as a team. So is vendor lock-in a risk? Absolutely. No one's going to dispute that, but is it worth the risk in most cases? Absolutely as well. I can say that from multiple experience in my career. But again, technology is not a silver bullet. You can't expect it to solve all the problems. In fact, I've seen many companies trying to use technology to solve their culture problems, their process problems. Of course, they always fail. And I do think that nowadays you should be using containers with serverless side by side because the platform themselves just have so many constraints. That means they're not good fit for many requirements. But you should have the sort of serverless first mentality whereby you see if something can be done serverlessly. If not, then you fall back to containers and embrace that. Whatever decision you make sure that you understand the trade-offs you're making there because you're always making some trade-offs, even if that is not apparent to you. Having control is well and good, but it comes with a lot of baggages. Understand those baggages and what it means in terms of total cost of ownership. Sometimes it's worth it, sometimes it's not. Make the best decision you can and choose wisely between when you use containers and serverless. Or you can, nowadays, there's other things like AWS Fargate that allows you to kind of get a mix of the two where at least it simplifies the work required to run a containerized workload. With that, thank you guys very much for your time. That's 163 slides in 30 minutes. Well done. Slides will be available afterwards, so I'll share on Twitter against the ITNEXT.
So again, thank yous to Jan. I think you're going to be here for the rest of the day.
Yes, yes.
So we have the open spaces, and I have lots of questions and a lot of topics to put into this there. So you have until lunchtime to put ideas there. And thank you again for coming.
Thank you. Thank you. Take care.
And now I would like to see where Penny... Oh, Penny's here. Penny will come to stage. People are switching rooms maybe, so you're going to have some free spaces. We turned off the heater so you don't die.